Okay, so let's continue solving more exercises. In these next 4 exercises from 13 through 16, we will have to differentiate functions, but in two different ways. In each one of them, the function like this one will be a product of two other functions. So first we have to use the product rule to differentiate the function, and then we have to multiply the factors in the usual way and get a sum of simpler functions. For example, if you multiply these two polynomials, you are going to get another polynomial, and then you differentiate. Okay, so let's see how it goes. So the first one is this, the 13th one. Because they have given names to these two ways of differentiating, so we also are going to write A and B. In part A, we have to use the product rule for differentiation. So we write like this: by the product rule dy dx. Of course, first you are just going to write what y is, and then only you apply the product rule, times x cube minus x plus 1. In order to emphasize that the differentiation is on the entire product, we are also using square brackets to enclose these factors. So now only we apply the product rule, and by the product rule, you can differentiate any one of these two first and then do the other. It's up to you. So let me first keep this one unchanged and multiply it by the derivative of the other factor. Plus, then we apply differentiation to that, to this one, and keep that other factor same, unchanged. Plus x cube minus x plus 1 times the derivative of 3 minus x square. So 3 minus x square times the derivative of x cube minus the derivative of x plus the derivative of 1. The derivative of x cube by the power rule is 3 times x square minus the derivative of x is 1 and the derivative of 1 is 0. Let's just write that. Okay, there is no point in being just as short as we can. That may create confusion. So sometimes you have to write some things, but not necessarily writing everything in detail all the time. Okay, so this much is okay. Plus, then this thing, x cube minus x plus 1 times the derivative of 3 is 0 minus the derivative of x square by the power rule is 2 times x to the power 1, so that is minus 2x. Now it's up to you whether you want to multiply things out and then do the usual stuff, or you can keep it like this. I'm going to keep it like this. Okay, I won't multiply, I won't do anything else. We just have been asked to find the derivative, and that's what we did. Okay. Does not matter in what form we keep it. Oh, because it is just minus 2x, so you can also write like this, minus 2x times this. So this is our answer. By the product rule we are getting this. Now next B. In part B what we do is, first we do the multiplication. We have, so that is why in the beginning itself we don't think of differentiating. First we do multiplication, simplify the resulting thing, and then only we differentiate. So we start with the given function x square times x cube minus x plus 1. And we do our usual multiplication. First we are going to multiply this by 3. That means each term will be multiplied by 3. So 3x cube minus 3x plus 3. And then again by minus x square. Minus x square times x cube is minus x to the power 5. Minus x square times minus x, minus and minus will give us plus, and x square and x is x cube. Sometimes we inadvertently or accidentally make the mistake of writing 6 here, because we may think that 2 and 3 will be multiplied. Don't make that mistake. You should be absolutely clear about what's going on here. When you have x square times x cube, there are 2 rules of exponents, right? In one of them, the exponents get added, and in the other, they get multiplied. If you have x square times x cube, then that is x to the power 2 plus 3. But if you have the cube of x square, that is x square whole cube, then 2 and 3 get multiplied. That's not the case here. Okay, so we have 5. And then what else? Minus x square times 1 is minus x square. Minus x square. Okay, so now we can do a little simplification. So this is equal to, first you consider the highest degree term minus, it's not necessary, but that's how we normally write, minus x to the power 5. Then the next highest degree term is the cube terms. The terms involving x cube. 3x cube plus x cube is 4x cube. Then the next highest, we do not have x square, we only have, we have x square, okay, yeah. I did not see that. Minus x square, that's the only square term. And then x term, we have minus 3x. Any other x? No. And then we also have a constant term plus 3. Okay, so now we are ready to differentiate. Now dy dx is, it's a good idea to first write the expression and then only you go for differentiation. Plus 4x cube minus x square minus 3x plus 3. Okay, so now we will differentiate using the various rules that we have learned. this will be minus, and of course we are going to use the power rule ultimately on each term. So the first one will be minus 5x to the power 4 plus, if you bring 3 down, that gets multiplied with 4 and it becomes 12, and then the exponent gets reduced by 1. It was 3 previously, now it is 2. X square will become 2x, minus 3x will become minus 3, and plus 3 will, it will just vanish because it will become 0. So, by the second method, this is our derivative. Now, I actually could have done the calculation here, but I purposely left it out because now what I want you to do, I want you to do the multiplication and I want you to simplify the expression and see if this is really this expression, because we should get only one answer, no? So you can do that yourself. Let's go to the next one. The next one is a similar one. Here y is x minus 1 times a quadratic polynomial x square plus x plus 1. So here also first we will use the product rule and then that other method without using product rule. By the product rule, dy dx is x minus 1 times x square plus x plus 1. And in this next step, we are using the product rule. So let me keep x minus 1 unchanged first and differentiate this. Plus, then we keep this unchanged and differentiate x minus 1. You may be thinking, if you can write the derivative of, this derivative term first and then this one, you can. But if you do so, make sure you use another set of brackets. Otherwise, it may accidentally look just like this, as if you are differentiating the entire thing. That's why I am carefully writing the derivative after writing the factor which we are not differentiating in that term. Okay. So now let's do the differentiation. It will be x minus 1 times usual stuff. If you differentiate x square, you will differentiate first. That will be 2x by the power rule. Differentiating x, you will get 1. And differentiating 1, you of course get 0. Plus, then x square plus x plus 1 times differentiating 1 gives you x gives you 1, differentiating x gives you 1 minus differentiating 1 gives you 0. So this time actually let's do the simplification. 2x plus 1, here you just have 1, so it's just x square plus x plus 1. Now if I do the multiplication, x times 2x is 2x square plus x times 1 is x, and then we multiply by minus 1, so that gives us minus 2x minus 1, and we already have x square plus x plus 1. Now further simplification will be there. 2x square plus x square is 3x square. The square term is the highest degree term. X plus x gives you 2x, but we already have minus 2x, so ultimately we are not going to have any x term. Similarly, 1 and minus 1 cancel each other, so we just have a 3x square. So that is by method A. And by method B, in method B, we do the multiplication and simplification first, and then we differentiate. X minus 1 times x square plus x plus 1. So if I multiply all the terms in this polynomial by x, each term gets increased in degree by 1. X square becomes x cube, x becomes x square, and 1 becomes x. And then I have to multiply them by minus 1. So minus x square minus x minus 1. Now you will see that this is, many things are getting cancelled, and ultimately you are having x cube minus 1. This is not an accident, because this has the form of a standard formula. It is in fact the factorization, algebraic factorization of x cube minus 1. So what we have used here is this formula. Let me show the formula here from classical algebra. You probably already have seen this. AB plus B square. There is a formula like this. Replace A with x and B with 1. What are you going to get? X minus 1. X square plus x times 1 is x, and 1 square is 1. Okay, so if you want, you can straight away use that formula, recall that formula, and straight away write x cube minus 1. So now dy dx is x cube minus 1. So now the job has become really easy. When you differentiate x cube by the power rule, you get 3x square. Differentiating 1 gives you 0. So you get 3x square, which is just the previous one. So you see that method B in this case gives us a shorter solution than that one. Whenever, see, this gives us the clear idea that it's not always a good idea to straight away use the product rule whenever you see a product. Sometimes the other way, that is this B, proves more fruitful. More fruitful means it gives you the answer more quickly. All right, next, 15. In 15 also we have a product, but this time we don't have polynomials. I mean, this first factor is a polynomial x square plus 1, but the second one is not. x plus 5 plus 1 over x. The presence of that 1 over x tells us that x is not equal to 0. As we discussed, we have already discussed this aspect that we won't really explicitly say these things that say when you have a denominator it is not 0. Those things are there in the background. Here we are more concerned about applying the rule and getting the answer. Okay, so first we are going to use the product rule. By the product rule, dy dx is x plus 5 plus 1 over x. X square plus 1 times the derivative of x plus 5 plus 1 over x. Plus we keep this intact and differentiate x square plus 1. So x square plus 1 times differentiating x gives you 1, differentiating 5 gives you 0. What do we get when we differentiate 1 over x? The more you use this, the more easily you will remember. But it's not, you should not, of course, straight away differentiate it in this form itself. You don't have to do that. You can use, in fact, this is where it's coming from, the power rule again. If you express this ratio like that, but now with negative exponent minus 1, the form of the derivative is same as the form of the derivative of a power where the exponent is positive. What you do, you bring that exponent down and then you subtract 1 from that. So we get minus x to the power minus 2 or 1 divided by x square with a minus sign, minus 1 divided by x square. I said the more you use it, the more easily you will remember. Actually, it's a good idea to at least remember the derivative of 1 over x. It is 1 over x square but with a minus sign. So minus 1 over x square and then this one plus x plus 5 plus 1 over x times 2x plus 0. So we will get x square plus 1 times 1 minus 1 over x square plus, let me write 2x first, times x plus 5 plus 1 over x. Again, this one I am not going to do the multiplication and simplification. I leave that to you. Instead, let me go to part B. So what was it? X square plus 1 times x plus 5 plus 1 over x. So now we do the multiplication first. So we are going to first of all multiply all the terms of this second factor by x square. Doing that, we get x square times x cube plus x square times 5 is 5x square plus x square times 1 over x, 1x gets cancelled and we have x. And then we multiply these terms by 1. It just gives us the terms back, that is plus x plus 5 plus 1 over x. That means we ultimately get x cube plus 5x square plus x is 2x plus 5 plus 1 over x. Note that this entire thing, although it looks like a polynomial, it's not a polynomial due to the presence of that 1 over x. It is a rational function, however. So, x cube plus 5x square plus 2x plus 5 plus 1 divided by x. So this one, when differentiated, will become 3x square. If you bring 2 down in the next term, it gets multiplied with 5 and becomes 10. And the exponent gets reduced by 1, means it will be x. Plus, differentiating 2x, you get 2. Differentiating 5, you get 0. And differentiating this one, as before, you get minus 1 over x square. So ultimately, what are you getting? 3x square plus 10x plus 2 minus x square. And again, I ask you to do the multiplication and simplification here and see if you are getting this. If not, then either this is wrong or this is wrong. It should not be, but at least check. And then finally 16. The 16th one is this. Here both the factors are not polynomials. X minus 1 over x plus 1. A. By the product rule, dy dx is d dx of this by now it has become clear that the second method B is proving to be much more easy in this case. In fact, the presence of this 1 over x and x, this is screaming for simplification. You do the simplification first and then only you differentiate. I think many things will get cancelled, but we have to use the product rule because that's the demand. X minus 1 over x plus 1. And then we keep this fixed and differentiate this. Plus x minus 1 over x plus 1 times the derivative of x plus 1 over x. And in doing all these things, no, suddenly do not forget that in the product rule we have a plus in between, not a minus. The minus thing you have in the quotient rule. So x plus 1 over x times the derivative of x is 1. Derivative of minus, okay, see, be a little careful here. Minus, or let me just write it like this, minus. What is the derivative of 1 over x? We have already seen minus 1 over x square. So use a bracket, a set of brackets, plus 0. Then plus x minus 1 over x plus 1 times derivative of x is 1 and that of 1 over x is minus 1 over x square. Alright, so this will become this times 1 plus 1 over x square plus x minus 1 over x plus 1 times 1 minus 1 over x square. This time let me do the calculation, okay, and let me see what we get ultimately. If we do multiplication, say we are going to multiply these terms by x, that will get us x plus 1 over x and then by 1 over x plus 1 over x plus 1 over x cube plus, here say I multiply, let me now do the multiplication from this side. We can do anything, right? We can multiply all the terms by 1. That will simply give us the terms themselves. X minus 1 over x plus 1. And then we multiply these terms by minus 1 over x square. X times minus 1 over x square is minus 1 over x. Then minus 1 over x times minus 1 over x square. Minus and minus become plus 1 over x cube. And then this times 1 is minus 1 over x square. Okay. Okay, so let's now write the terms by going from higher degree to lower degree, including negative degrees if you want to say so. What is the highest degree term here? X. So x, x and no other x. So 2x. After that, the next higher degree, that means the 1 immediately after that is a constant term. There is only one constant here, 1 plus 1. Then if we go below that, this is x to the power 1, x to the power 0, then x to the power minus 1. That means 1 divided by x. So 1 divided by x, if you think of that, here we have 2 of them. And here we have 2 of them but with minus sign. So they get cancelled. So there is no net 1 over x. Then 1 over x square is there, okay, there is one term. Minus 1 divided by x square. And then what about x cube? I mean 1 over x cube, this one and this one. So 2 divided by x cube. So that in that way we can express the final answer. But now let's see what happens in part B. So in part B, we have to do the simplification first. X plus 1 over x times x minus 1 over x plus 1. Is that what we had? Yes. So multiplying these terms by x gives me x times x, x square, x times minus 1 over x minus 1, because x and this, they get cancelled, plus x times 1 is x, and then we multiply by 1 over x, plus 1, this one times this one, minus this times this is 1 over x square, plus 1 over x times 1 is 1 divided by x. Okay, so x square, and then we have an x term, right? So x, and then there is no constant term actually, because minus 1 and plus 1 vanish, then 1 over x and minus 1 over x square. So now if we differentiate x square plus x plus 1 over x minus 1 over x square. So differentiating x square gets us 2x. Differentiating x gives us 1. 1 over x, when you differentiate, you get minus 1 over x square. But what about this? This we don't, we know, but we haven't seen this. So let me show it here. Originally it's minus 1 over x square. Okay. So this is d dx of minus x to the power minus 2. Minus means minus 1. By the constant multiple rule, minus 1 comes outside. And then by the power rule with negative exponent, same form, minus minus 2, the exponent comes down, and then x to the power minus 2 minus 1, you subtract 1 from the exponent. So minus and minus become plus, 2 times x to the power minus 3, that is 2 divided by x cube. So that last term will be plus 2 divided by x cube. See, we are getting the exact same thing. So that means it's okay. So let's just keep it till this only. There are so many more exercises. We will solve most of them slowly. And tomorrow we have our usual linear algebra, where, we will see what there is tomorrow. So that's just it for tonight. See you tomorrow. Until then, this is me, Lucifer, from A Mathematical Room. Have a nice night.